Welcome, friends. It's exciting to see folks from all over the world tuning in today. Thanks for sharing your location in the chat. You know what time it is, though. This is another installment of On.NET Live. And our mission here on this show, if you haven't tuned in before, is to empower the .NET community to achieve more, really learn about what folks in the community are doing with the .NET tech stack. I'm your host today, Scott Addie. And I'm joined by co-hosts Maira Wenzel and Cam Soper. Today we have a show with our guest Fiodar Sazanavets, who will talk about SignalR. Fiodar, before we get into that topic, I'd like to toss it over to you to briefly introduce yourself.
Yeah, sure. So my name is Fiodar Sazanavets. I'm originally from Belarus, but I live in London right now. I've been specializing in .NET for over 10 years now. I'm a Microsoft MVP, and some of you may know me as an author of a couple of .NET related books, such as The Easiest Way to Learn Design Patterns, and there is one on SignalR that I wrote a while ago as well.
Awesome. So you wrote a book on SignalR. You've been doing .NET for a decade. Chances are you know some things. What are we going to talk about today? Well, I guess I'll take a step back even from that, and I'll say, well, what is SignalR for folks in the audience that are wondering, well, what exactly is this thing we're going to focus on today?
So SignalR is a library inbuilt in ASP.NET Core. So essentially, it's one of the libraries available out of the box. You don't need to install any additional NuGet packages to make it work. And the purpose of that library is to facilitate a real-time communication between the client and the server. by also abstracting away all the complexity. So, for example, you can do so with the WebSocket, but to do so with WebSocket is fairly hard because you have to kind of split the message into bytes, then reassemble the message on the other side. When you write code in SignalR, the way you do it is basically just by specifying method names on the clients and the server. So your code looks as if you are invoking server methods from the client directly and vice versa. So it's highly applicable in applications such as chat, live tracking of delivery, or as I'll be talking today, controlling clusters of IoT devices. What I'll be presenting today is actually based on a real project that I did a while ago, and that was one of the most exciting projects I worked on.
Yeah, I'm excited to get into that. So, thinking back to my first experience with SignalR, it was a game changer for me. Looking at the ability for the server to send a notification to the client that something had been completed.
Yep.
Mind blown. I was like, that it just opens up so many possibilities in your applications.
It does. Well, SignalR is based on some other technologies, and you can do all of that without SignalR. But SignalR makes it so much easier to do.
Yep.
This is why I love it.
So why don't we get right into it then? My understanding is you have some code samples you'd like to share with us.
I do indeed, yes. So let me just share my screen. Let me see. Can you see the tab in the GitHub repo that I'm showing?
Looks good.
Right, okay. So I'll give some background of the project that this repo represents. A while ago, I was working for a railway information systems company, and we implemented this technology. The problem that we were trying to solve is to make train announcements compatible with text-to-speech, because the way train announcements were made at train stations traditionally is by hiring some voice actor. Then that voice actor had to pronounce all the names of the stations. Then those files were saved on the device at the train station, and it was done in a dumb way as well. So, for example, if there's a new station that was being built, then the voice actor had to be rehired to pronounce that name as well. And also, those devices did not know of each other, because even though those devices were computers, they were not connected to a network in any way. Well, they sort of were, but in a fairly dumb way. So we came up with a system where each platform had its own device. Those were just single board computers. We started with Raspberry Pi, but we then moved on to more commercial grade computers, more durable devices. So we solved the problem where if the train wants to approach the station, it would then construct a sentence that would be sent to text-to-speech service. That sentence would then be announced by the device itself, and also those devices knew if any other device at the station is talking. So they would never talk over each other, because that was a big problem as well when you're trying to get information about an upcoming train, and then suddenly a device from another platform interrupts it and tells you that smoking is not permitted at the station. In this situation, it would never happen because devices located next to each other would act as a single cluster. And this repo demonstrates how this was implemented by using SignalR.
Fiodar, if you don't mind, we have folks in the audience that are asking you to increase the font size. Could we bump it up just a little bit?
Yeah, sure. Is this better, or shall I increase it a bit more?
That looks good here. Yep.
I can do this.
They're saying it's good.
It's a project I did a while ago because back then the experience was fairly recent. Inside this project, there are two very simplified versions of the application. One of them is called IoT Hub Host. So this is the application that resides on the server. This application represents SignalR Hub. And IoT Device App is just a console application that was deployed on IoT device. Because a good thing about .NET or .NET Core when it just came out was that you could write the same code and then run it on many different platforms. So essentially, we could develop our code on Windows and then put it on Linux devices. Before I start, I'll demonstrate how easy it is to set up SignalR. This particular example still uses the old style, where there's a program file and there's a startup file. But the principle is still the same.
So I have a real quick question for you, Fyodor. So what kind of system? So you mentioned that you guys are developing on Windows and deploying on Linux. What systems are you guys running for your server and for your IoT devices? Are those like single board computers? What are those?
Right. So the system that we were running on single board computer, the operating system was a stripped down version of Debian Linux. I can't remember exactly. I think it was Linux Mint, to be honest. Yeah. We started with Raspbian because Raspbian is the distro that Raspberry Pi uses.
Right.
And then we moved on to Mint because that particular OS was basically a version of Debian that was supported by those specific devices the best. The server-side application was running in Azure. That particular one was running in Azure Service Fabric, which is not very common technology for distributed apps, but we essentially had a cluster of microservices. And one of them represented a SignalR hub. So what I'm showing you now is a startup code for the server-side SignalR hub. The principles are similar in the modern applications, which just use the program.cs class, because it's a fairly old repo. It's over 2 years old. It still uses a startup. So essentially, what we're doing here is adding SignalR dependencies by invoking add SignalR. And in here, we are mapping a SignalR hub. We are mapping this hub to a particular URL. Now I will show you the hub itself. So a SignalR hub is essentially, it's very similar to a controller. Each hub method has an arbitrary number of parameters. It inherits from the base hub class, which comes from this namespace. And essentially, any method that is public and async can be registered as invocable from the client. So any method that is not overridden, because this particular one, for example, is a custom logic associated with onDisconnect event. It's a custom thing that happens when client disconnects. But all other methods are invocable from the client. And if I'll now go back to the client app, so this application represents the app that would go onto the IoT device itself. To invoke one of these methods, this is what you do. So there's a connection object, which we are creating here. So we are specifying the path to our SignalR hub. We build it. It's a name of the method, so that there's one-to-one relationship between C# method name and event that we are invoking. There are any arbitrary parameters, but they have to match the data types and the quantity of the parameters that the method supports. But other than that, that's it. So basically, it's as simple as just, or it's almost as simple as invoking the method directly, even though what happens behind the scene is quite complex. And also, to listen to server-side events, we have this on handlers. So, for example, when we are invoking receive work client-side method, this particular event gets triggered. Or if we expect a particular data type to be returned from the server-side events, we can also apply a generic version of this on method.
I have a question for you, Fiodar. So I mentioned, or I noticed in your connection that you were building further up in this file, you have a local host URL. I'm wondering, how does that change as you deploy something like this to a cloud like Azure?
Yes, so this particular URL is just hard-coded to match the URL of the application, just to match the value from launch settings.json file from the other file. But essentially, it's just the HTTP address of your application, so it can be any custom URL. If you host it in the cloud, it's going to be some kind of DNS, some kind of address you specify, or maybe it's an address that Azure gives you. But this path here needs to be the same as the path that you configure in your hub registration code.
Got it.
And those named events that I showed on the client side, they correspond with this. And this is the client side. It's a named client side event that we are invoking here from the server. So essentially, once we establish this connection from the client, the connection between client and the server remains active until we disconnect the client or until something happens to the network itself. When the client chooses to disconnect, we are triggering this on disconnected async event. There's also another overridable event on connected async, which we can override to trigger some custom logic when client connects. The way we implemented it is that every application that we deployed on the device also acted as a server. So you acted both as a server and as a client for SignalR.
I was just going to ask a question real quick. That on disconnected async method that gets fired when you said when a device chooses to disconnect from the hub. What about when, like you mentioned earlier, when there's a network issue that forces a disconnection?
Yes. This is why we have this exception parameter. So if exception is null, if it's just a normal disconnection, if a client willingly disconnects, this exception will be null. Otherwise, there will also be error information.
Got it.
The way SignalR manages it is by sending a payload both ways over the network. It's just a small JSON payload. And this is how it can assess that connection is still active. So it can detect disconnections automatically.
Is there any concept of a retry in that case? Like that message could be, or that communication could be retried?
There is a concept of retry as well. And on the client side of SignalR, it can also be configured to retry and try to reconnect automatically. But that message is not like a retry, it's like a heartbeat message. So basically, we know that connection is active because expected heartbeat arrived within a specific amount of time. But it's all managed by SignalR itself. We don't have to worry about it too much. We can fine-tune it. I do have a chapter in my book about how to fine-tune it, how to change those values. If I'm not mistaken, by default, it's every 30 seconds. So if we did not have message within 30 seconds, then connection will be detected as disconnected, as broken. But we can change that value if you wanted to. Or maybe it's 5 seconds. Yeah, I can't remember off the top of my head. But that value is configurable.
And is my mic working? I just want to make sure.
Yeah, it's working.
Okay, awesome. One question that I had, you mentioned that you configured that in your case as a client and a server. When do you think that's a good use case, and when do you don't recommend that?
Do you mean use case for SignalR in general, where you connect clients to the server?
No, you mentioned that each server was configured as client and server at the same time.
Okay. So the reason for that particular configuration in our case was because we were running devices of a train station. Some train stations had very bad network signal. So we could not have like all 4 or 8 devices talking to the network at the same time, because some of them might not be able to succeed. So the way we did it instead, to save the network bandwidth, is nominate. We had an algorithm that did it automatically. We would essentially nominate one device as the main device, and that would be a device that would be connected to the cloud. And the other devices would be connected to that main device via internal network. So it's only one device communicating with the cloud. It will then convey any information to appropriate recipient device. Let's say there is a configuration where the main device is located on platform 2, and the train is about to arrive on platform 4. What happens is that the device on platform 2 picks up the announcement for the device on platform 4, and then it sends that payload to the device on platform 4.
Got it.
But in most other cases, you will have each client connected to the server directly.
Okay. Yeah, no, but it's interesting. So it's like it was a case where you cannot guarantee that you would always have the connection between the server and the client. So you were doing that. Cool.
Yes. But because SignalR is capable of detecting disconnections automatically, we also had an algorithm in place. I don't have it in this particular repo, but we had an algorithm where the system would reconfigure itself, and another device will nominate itself as the main device. And one of the benefits of having this kind of configuration in that specific scenario was that whenever a device was making an announcement, all other devices were able to detect it. So essentially, I have an example of this in this do work method. Real life application of this method was that whenever announcement starts on one of the devices, all other devices next to it in the same cluster know about it. So whenever a payload arrives on any other device, when any other device gets signal to make its own announcement, it will hold off until the first device stops its own announcement. So you will never get in a situation where 2 devices are talking over each other. But for example, in this particular case, we also have timeout. It's good to have timeout for things like this, for distributed applications, because sometimes something may happen while one device is making an announcement. So let's say you never expect an announcement to be more than 5 seconds. So you have timeout of 5 seconds because you know that if it did not complete talking within 5 seconds, then it's not that it's still talking, it's just the device did not receive the signal to clear its own flag so it can start talking.
We're getting some questions from the audience. So Alberto was asking, so everybody broadcasts to everybody?
Sorry?
So Alberto was asking if everybody broadcasts to everybody.
Oh, no. So I will come back to my hub code. You don't have to broadcast to everybody. You have concept of groups in SignalR. I think it would be better. Let me know if you can still see the tab, because I'm changing this layout to code spaces.
Mm-hmm.
Yes. Okay. Yes, it's much easier to navigate, but I'll probably add the font again. Okay.
Perfect.
So SignalR has different ways of I probably won't be able to pick definition in the browser, but anyway, SignalR has a concept of groups. So in that particular case, one group may represent a single cluster. So you are only broadcasting to devices in that particular group. You're not broadcasting to everybody. SignalR also has a concept of connection ID. So whenever device connects, it comes with auto-generated GUID, which represents individual connection ID. And that connection ID can indicate individual device, individual client. So with SignalR, you can send messages to a specific client. In this case here, the reason why I'm calling some custom code on disconnected async is to notify the server that particular device has disconnected, has essentially left the group.
And where are you defining the groups?
So in this example, devices get assigned to groups when the first received device connected method is invoked.
Does the device like declare its area name when it connects?
Yes. So typically, in our case, the device ID would be a serial number. So it's something that you can use to identify individual device. Area name was things like platform name plus station name. Or actually, in this case, area name might be station name, and location number might be platform name, platform number. And I have these helper methods here, which for some reason I cannot navigate. Oh, here we go. So I use various collections internally to associate devices with, to associate connection ID, which is the GUID that gets randomly generated, with something that is identifiable and human readable, such as device serial number. So, for example, this method here, remove device connected, removes this device from the dictionary of connected devices. And there are things like location mapping and area mapping.
Okay. And
So-
what, like, oh, go ahead, Scott.
One question I have, Fiodar, I know it can be challenging with SignalR applications when you deploy them in a server farm environment, as most production environments are. There's multiple servers involved, and so you need to find a way to ensure that the client is always communicating with the same backend, the same server. And
Yes.
so things like sticky sessions come into play, or session affinity. I'm wondering, in that case, is there any kind of backplane like Redis or SignalR service that you're using?
Yes. So I'll show you two examples. I'll show you examples of both. I will just share a different tab. Okay. Let me know if you can see it.
Mm-hmm.
Yep.
Okay, so this is a code sample from my book. And it's from chapter 9, which provides example of Redis backplane. So if I go to the setup code, here we go. So if you want to scale out SignalR yourself, or you might do it with Azure as well, because Azure supports Redis. But SignalR out of the box supports, well, not necessarily out of the box, because you have to install a NuGet package to enable it. But it's a NuGet package that was created by the same people who created SignalR. This setup code, which adds SignalR dependencies, adds SignalR, can have another method chained to it called add_stack_exchange_redis, where you just specify address of your Redis application, of your Redis instance, and then that Redis instance acts as a backplane. So essentially, if you have a distributed SignalR hub, if your client connected to a particular instance of it, then this backplane allows to track which instance each client is connected to. So if you identify that members of a particular group, so the specific clients that belong in a particular SignalR group, are spread out across many different servers, it will still correctly identify each one of them. And if you're also trying to send a message to a specific client, you will still get to the right client, even though, even in a situation where the originator of the message was connected to a completely different instance of the server. So this is something that you can even do in your own development environment. But there's also another way, which is by using SignalR service. So Azure, I keep clicking on the wrong thing. So I need to.
And just for clarity, this is not SignalR. This is an actual service that's running in Azure for folks that are wondering.
Yes. So you still have your hub, but the actual service is running in Azure. So this invocation here, add Azure SignalR. You can then specify the connection string to that server, to that service. Yes, so all of this, all the scaling out will be outsourced by your Azure service. You will still run the code in your hub or on whichever service you are running, but things like client connections will be managed by Azure. So, for example, that will still run on your service, but all the connection-related information and all the metadata like clients, groups, and so on, that will be managed by the service in Azure. And also, this particular example provides you with examples of how to trigger various things. So, for example, if I do this, client.others, it means that whichever client has sent the message to this endpoint, it's going to be all clients but the client itself that will receive this message. If you say all, it means it's all clients, including the original client that sent the message. There's client with connection ID, as I mentioned before. So if you specify a connection ID of individual client, it will only be that particular client that receives the message. Or you can do things with groups. So it's going to be any clients that belong in that particular group. This is, for example, how you add clients to a group. So you specify connection ID and then just map it to a group name. You can remove from group and so on.
So I want to get back to this concept of the backplane that we were looking at. You showed both Redis and SignalR. And so myself and probably many other viewers at this point are wondering, which one do you choose and why? Do I go the Redis route or do I go with SignalR service? What are some things you consider to make that decision?
So my decision would normally go would normally be to go with the SignalR server because then it's fully managed by Azure. You don't have to run anything locally. You don't have to configure as many things. The main disadvantage of that is that for some things that are started in SignalR, the code is different. So if you've been using SignalR for a while and you are new to Azure SignalR service, then you have to do a bit of learning because, it's just too different. With Redis backplane, the only thing that you do differently is that setup code where you specify when you invoke add Redis Stack Exchange. That is literally the only difference. Everything else works exactly the same. But if you're running, if you're scaling out your own server farm, I would probably go with Redis.
Got it. We have a related question that I'll put up on the screen from our friend David. David's asking, what's the smallest footprint cloud-hosted SignalR costs as a service to use with Azure? I think what the question's getting at is, what's the most efficient way to run something like this in Azure without breaking the bank? So if cost is a concern, what would you recommend to David?
Yeah, I don't think I'll be able to answer this question because it's been a while since I ran it at a large scale in Azure.
Yeah, so David made some clarification here. I'll put that up on the screen. So asked another way, what's the lowest cost way to provide real-time text chat using the Azure SignalR service?
Yeah, I can't remember exact figures, but we were running it in a small company that managed all live train movements for entire England. So even with that, it did not cost us that much, but I can't remember the exact figures.
Yeah, there's a related question I'll pop up on the screen asking, is Azure SignalR service more expensive than the Redis solution? One thing I'll say here, and then I'll let Fiodar chime in. There is an Azure cost calculator you could use to get an idea of, if I were to run this particular tier or SKU of the service in my Azure subscription, what would that cost me? Do you have anything to add, Cam? Or
well,
Fiodar?
I was just going to say, Scott, I think, and I don't know which one's going to be ultimately more expensive. The last time I looked at it, which was a while back, the SignalR service was a little bit more expensive, but there are like services in Azure that there are more than, just like with .NET in general, there's often like a dozen ways to accomplish the exact same task. And just like, I'm just guessing, don't quote me on this, but just like from my gut, I'm going to say that using Redis and rolling your own SignalR hub is probably going to be cheaper than using the Azure SignalR service, is my guess. But it seems to me that the Azure SignalR service is going to, being kind of that software as a service offering, is going to be more simplified, right? Fewer things to maintain, fewer things to deploy, and so on. Just my guess.
I think Redis will be cheaper just because you have much more control over it, because it's your Redis instance that you're controlling, it's your code that connects to it. While with SignalR service, you're pretty much outsourcing all the meaty bits to Azure. So yeah, even if it's not cheaper by default, it's probably easier to make it cheaper just because you've got more control over it.
We have another question. It's awesome to see all of the questions coming in here. This question speaks to the hosting aspect. Can you host SignalR in a Linux container?
Yes, I have done it before. Well, as a matter of fact, the example that I gave you is example of that, because the application on the device was deployed as a Linux Docker container. And the way we run it is that one device acts as a main device, and it acts as a SignalR server for all other devices in the cluster.
Got it. Andrew has another great question that I'll put up on the screen here. WebSocket support in various Linux distributions. What does that look like?
I don't think I ever came across a Linux distribution that did not support WebSockets, because it's a fairly standard protocol.
Yeah, the thing I would say here to Andrew, so in the case that WebSockets isn't supported, correct me if I'm wrong, Fiodar, but SignalR does have knowledge of how to degrade the connection gracefully. So it will attempt other methodologies for connecting. Server sent events, I believe, is one of those.
Yes, so you don't have to use WebSockets. WebSockets is the default protocol that SignalR will try if it can. But if it cannot, or if you specify something else, because you can explicitly specify supported protocols. It also supports server-sent events, and if for whatever reason it cannot support that, it will fall back to long polling, which everything supports. So anything that supports HTTP will support long polling. From the development perspective, it does not look different at all, and that's the beauty of SignalR. Your code will look exactly the same. Your setup code might look different if you want to explicitly specify any of those transport mechanisms. But if SignalR itself is forced to choose a fallback mechanism because WebSockets are not supported, then your application will not look different at all. It will be slower for obvious reasons, because WebSocket is a protocol that was explicitly designed for high efficiency real-time communication between two entities on the network. While with long polling, your client will be making a request and will wait for the server to respond. So essentially, socket will be open for that. And then once the server responds, it will make another request, and so on. So it's going to be much less efficient. But from functionality perspective, it will look exactly the same in SignalR.
And David was also asking, do you have that Linux container example in one of your repos?
I don't know, because it was a proprietary Docker container that I used when I used to work in that place. But essentially, it's very simple. All you do is just open the port as the outbound port, as you would normally do, to make Linux container accessible via HTTP. And then you just send a request to that particular port to the path of your hub. So it's not different at all compared to calling REST API or GraphQL with a Linux container.
And George was asking, what about concurrency in SignalR hubs?
What's specific about it?
I don't know. We'll see if he clarifies the question then.
This question actually made me think of something. So from a design perspective, how do you know that you should create a hub? Like, what's the rule of thumb? Do you have one hub for your entire application? Do you have multiple hubs? Maybe that's what
the
this
way I
question
think to do it is implement single responsibility principle. So it will be similar to how a lot of people use controllers in the classic ASP.NET Core without minimal APIs. So it will be controller per functionality or per entity type. So it might be, for example, one hub that processes the audio, one hub that manages the devices, because, for example, one of the things that you want to do is manage those IoT devices from the server remotely. So that functionality is different from the functionality of transferring and playing audio, because otherwise your hub will just grow in size. But with SignalR, you can have as many hubs as you want. So essentially, you can register as many of these as you want to.
And he tried to clarify, like, since it's real time, you need to handle all actions taking care of concurrency, right? So maybe from what I understand, SignalR takes care of that for you. And
so with SignalR, like, for example, to prevent race conditions, because it's all kind of asynchronous communication between the client and the server. With the network itself, you cannot guarantee which message arrives first. But SignalR has also concepts of streaming. So you can stream messages from client to the server and vice versa as well. This way, if you do that, then you guarantee the order of delivery.
so it depends on what kind of application you're building. If you require that order of the messages are important, then you need to control that. Otherwise, you can just
yes. And with SignalR, you can control that by applying streaming, which I might have example of. Let me just check here. So if I go to my main hub, yes. So for example, this is a server-side stream. So client makes a call to it, and it triggers a stream from the server. And then the client receives messages in a particular order, via this for each. And that is client stream. So the input parameter of that is async enumerable of particular type. And we iterate through it here. So this is essentially the way of receiving messages from the client in a particular order. And this is the way of sending messages to a client in a particular order.
Yeah, thinking of, let's take this question first, and then I have one after. Go ahead.
Yeah, Janice was asking if you ever use SignalR on Metal.
Not in my current project, but in some hobby projects, I do use it because at the moment where I work, we just don't have use for it, at least not yet.
Okay. Yeah, hobby projects work.
Well, and I'm interested in that. So I know Meadow supports .NET Standard 2.1. So can you just run SignalR clients on that, or do you have to like fall back to like long polling mode or anything like that? I mean, does it have like full SignalR support on Meadow?
Well, with the SignalR support, you can still do things like long polling. So yeah, it sounds like you should be able to do that.
Okay.
Yeah, I'm just not sure if it supports WebSockets, but your application will function exactly the same way, at least visibly. So the only difference is going to be the bandwidth of the network that you're going to be using. It's going to be higher with long polling.
So for our viewers who are asking what is Meadow, I'll give a real brief explanation and then we can move on. But so when we were talking earlier about IoT devices, Fiodar was talking about using single board computers like Raspberry Pi. But we can also run .NET on microcontrollers like ESP32 controllers. Meadow is a microcontroller that is specifically designed to run a version of .NET, like directly on the hardware. But it's not exactly the same as Nano Framework, and I wouldn't even say it's exactly the same as like .NET Core. It's a subset. But that's all. That's my explanation for Meadow.
One thing that we did where I used to work, we connected a pure WebSocket client to a SignalR hub. This code here shows example of how to do that. So with SignalR, you have this JSON that is being sent, which acts as a handshake to initiate the connection. In one of our projects, one of our partners had a client that supported WebSockets but did not support any additional libraries. So we couldn't run a SignalR client on it. But we could still connect it to SignalR Hub, and it still acted the same way because we could just write a WebSocket client for it.
Awesome.
And that was my microcontroller as well. So Meadow might be able to support WebSockets. So in a nutshell, it does not have to support WebSockets to support SignalR. But even if it does support WebSocket, but you could not install SignalR client on it, you will still be able to make connection with SignalR Hub. It's just going to be a bit harder. So here's an example of WebSocket code. As you can see, we are assembling and disassembling byte here. SignalR abstracts away all this complexity. So obviously, you will get less benefits by connecting the WebSocket client directly to it. But if you have to, you can't do that.
So I guess as we're talking through this, one question I have is, what is the easiest way to know which communication mechanism is being used by SignalR? Is it WebSockets? Is it server sent events? Is it long polling? I assume you could look at the browser dev tools and see the WebSocket connections being made.
Yes. So that can be seen by toggling your login complexity, severity level in your logs. If you make it verbose enough, I think it's either information or debug that will give you that information.
Yeah,
both on the server and the client.
I suppose that could be useful if you're trying to tune the performance of your application. Just knowing, is WebSockets being used or not?
Yep. Or if you explicitly set it in your code, if you just set it as WebSocket as the only supported protocol, then you will know right away because it just will not connect.
So I want to dig into that. let's say I have a situation like that, and I know WebSockets is supported. Nothing else should be attempted. How would I configure that in my application?
So here are some examples of this. You can configure it on both the client and the server. So if I'll dig into client first. So here's the parameter, HTTP transport type, WebSockets. So in this case, by passing these additional parameters, I'm forcing only WebSocket on the client. I can also do the same on some other clients. So if I open Blazor client, I just need to remember where I put this code. I think it's here. It will be the same way here because it's also Blazor client is a type of .NET client. Let me find the server code. So here are some settings that I talked about previously, like keep alive interval, maximum message receive size, handshake timeout. So if you ever have to tweak them, this is where you do them. And if I remember correctly, yes, option transports. So in this case, I'm supporting only WebSockets and non-polling. This server is not allowed to accept server-sent events.
And that's interesting. Am I able to change the ordering there of the transports? Which one's attempted first?
I'm not sure about this because I never thought about it. You might be able to, but yeah.
To be honest, I don't know if there's even a use case for that, but I just thought of it as I looked at that code. Maybe there is a use case for it. I'm not sure.
Yeah, I'm pretty sure that this will give you the same value regardless of which order you put them in, because it's by bitwise OR.
Yep, got it. Now, I'm thinking of a situation now. This is the question I was going to ask earlier. Let's assume I've built a single page application using React, and I've deployed that to a completely different domain than where the SignalR app is running, where the hub exists. Do I have to use something like cores in that situation?
Yes.
And then that's, I assume, configured in this same file.
Yes. So essentially, the same way you configure cores for ASP.NET Core in general, this is how you do it for SignalR as well.
And yes, as pointed out in the chat, Fiodar has a sample for everything. This is awesome.
So what I've done here, I do have my book, and all the code samples from that book are available in a free repo on GitHub. And I basically opened every chapter as a separate tab.
Yeah, and I asked this question because just in talking to customers, I know this is a very common scenario where you've got an existing single page application and now all of a sudden you're being asked to modify it so that it can use something like this ASP.NET Core backend. It is possible, as Fiodar just showed. You have to enable cores.
Yes, so because your initial SignalR request is just a normal HTTP request, it works exactly the same way as any other course configuration in ASP.NET Core. So it's course configuration that you put in your application, and there might be some additional course configuration you have to apply in your host environment.
Yep. Our friend Alberto is pointing out, it sounds like Alberto has an idea here to use this for a .NET MAUI project. Yes, I suppose you could use it there.
You can. So yes, because .NET is one of the supported libraries for SignalR. It supports anything that supports .NET as a client. Also with MAUI, you can have your application UI done in Blazor. MAUI actually supports Blazor, and Blazor does support SignalR as a client.
And someone was also asking about MVC, which I also think it would be possible as well too.
Yes. So with MVC, you will just configure your JavaScript client. By default, the clients that are supported by Microsoft, there's a library for JavaScript, there is a library for Java, and there's one for .NET. I think the Java one was not maintained for a while. At least last time I checked, it was fairly old. But there are also other programming languages that you can find the clients in on GitHub. I think Microsoft stopped writing clients in other programming languages, but I believe that community picked it up. So the other day I found a client for SignalR written in Go, for example, and it definitely wasn't written by Microsoft.
So I'm thinking of one more question for you, Fiodar. Let's assume I have a hub that I only want certain clients to be able to use. Is there a way to secure that hub so that only members of a certain group can access it?
You definitely can, yes. So here I've got configuration that you would normally apply in ASP.NET Core. The same way you can secure any ASP.NET Core endpoint, you can secure your SignalR hub as well. So if I go back to the hub, yeah, it's just authorized attribute, it's allow anonymous, the same way you do it in controllers. And all the configuration that you apply to your middleware is the same as well. Yeah, as I showed here, so it's add authentication. You do various configuration here. There's some custom logic I applied here because if you use the WebSockets with SignalR, the bearer token will not come in authorization header. It will come in access token query string parameter. But that's about the only difference.
Awesome. Going back to the cores conversation, our friend Fuel Snibble says, whenever someone says it's a core issue, I mentally go blank. Yes, me too. You're not alone.
Yep.
With that being said, do you have any tips or tricks you would offer for troubleshooting cores issues, specifically with SignalR?
Usually the browser will tell you if it's cores issue. With .NET clients, it's slightly harder, but if you're using JavaScript clients, so what I tend to do with SignalR, whenever I was developing an application in it, even if I did not intend to use in-browser JavaScript client, I will still have some kind of a test version, because using DevTools usually gives you more information than SignalR logs would give you alone.
All right. Cam, Maira, do we see any other questions in the chat that we haven't addressed yet?
No, I think that was all. So I think, I don't know if Fiodar has any last thoughts that he would like to share, since we're coming to our time here. Like any last wisdoms to share with our community before we...
No, I can't think of any.
All right. Well, then I'd say let's wrap things up. I'd like to thank all of our viewers, as always, for continuing to tune in and soak up all the good knowledge here. As a reminder, we do have recordings like this show, as well as other shows available out at dot.net/live. Do head over there, check those out, leave some comments. If you tune in next week, we'll be joined by our familiar guest, Swami, who will join the show to talk about building a ChatGPT clone using Blazor and Azure OpenAI. So sounds amazing, Blazor and AI. What could possibly go wrong? Hope to see all you next week. And again, thanks to Fiodar for sharing all of his expertise today. Really appreciate it.
Happy to be here. Bye.
Bye.